Hello and Assalamu alaikum. My name is Bakisha. In this video, we are discussing about USART in Atmos Studio, that is with the AVR32P chips that we are using for the Arduino Atmega 3838P chips. So in this major topic is of master and slave. In USART, we have serial communication. That is, we take input from um, one of the megas inputs and outputs, and by serial communication by using TX and RX pins, we give to the data to the second UNO or any other microcontroller, and we take input from that. So similar is the case in this scenario, that is we are using Atmega 328P chip as a input, that is acting as master, and we are giving it to the slave, and the slave is giving the output. So what happening over here is that we have a push button, and we are when giving the signal input, it gives the output to the serial communication, the signal to the second Atmega 328P chip, and it takes the signal, and according to the program that is stored in it, it gives the output on the LED as the on and off. If we move on towards the next, that is SPI master slave communication that we are using over here, is that similar is the case happening in this task, that we are taking input from the hex keypad, and what we are doing that this hex keypad is giving the data to this at Mega 328P chip, which is not connected to LCD, but this chip is connected to the second Atmega 328P by RX and TX pins, and that data that we are giving input from this calculator, it is going into this chip, and this chip is communicating with this Atmega 328P IC, and then the output is generated by this IC, and we get the same input that we have given to the hex keypad by another Atmega 328 PIC, in which we are not giving the data, actually we are giving the serial communication, it is transferring that data. So if we move on towards the code of these um, tasks, so over here we have this is input output library, we have standard library. So here we have 16 megahertz clock declaration. We have delay library called and included, and in this we have int main function. So what's happening over here is we are declaring the pin port D pin 0 as input pin, and port C as the output port. So over here we have UBR value of 103, that is 2400 band rate. So then we have set the upper bits of UBR 0 register, then set the lower bits of UBR register, then we are the RxEN bit 4 to enable receive, TxEN bit to 3 to enable transmitter, and then we have USBS stop bit selection on bit 3 of USCRC UCS at 0 to select data bits of our character size on bits 1 and 2 too. So then we have a variable to store receive data, then we check to see if data is being received. If the data is received, store the value present in the UDR register, then we compare the received data and toggle bit 0 of port C on and off for the LED. So if we move on towards the second program, that is task of measure of master. So and similar, we have included the IO library, then we have declared the 16 megahertz crystal, then we have a delay library, then we are using pin 1 of port D as output port, and we are pin 0 of port D as input port. So then we have, as declared before, we are declaring the band rate of 4200, then we have put the upper part of the band rate number here with 8 to 11, and put the remaining part of the baud rate number here. Then we are using enable to receive the transmitter. Then set to stop bit, and data bit length is 8 bit. Once button is pressed and once transmitter is ready set 8-bit data and get the data output here. So this was for calculator that if the button is pressed, we get the output. So in this way, our tasks are completed for this lab. Thank you for watching the video.